Hello, welcome to the next episode. Today we will be discussing about file systems that are suitable for embedded ecosystem. This video will provide a summary about my research and my thoughts about the topic. Without further ado, let's begin! Before next Yasboot implementation episode, we have to do research about file systems. Problem to solve is, firstly, the Yasboot implementation must select image that will be booted. In order to achieve scalability, I need to utilize a file system. And I want to keep some configuration file for bootloader. For example, to select image to be loaded, to do some configuration, to enable some interfaces with user. So I need to store that configuration file somewhere on the flash memory. And I want to make possible to edit that file from the microcontroller itself. And with usage of file system there is an issue. How to execute in place the binary that is placed inside the file system. Most implementations of file systems that are capable to write are using chunks to store the data. And I need to get a file system that will place files in contiguous memory. At least those files that I need to. And additional information about the image itself. It will follow a custom format for dynamic loader. So I'm not going to use ELF files because they are too huge. I also want to create some recovery partition or recovery image that will boot if the primary one is not working. Another feature that will be supported by Yasboot, it will be extendable via modules. So basically I need to use some very simple file system just to get modules and then load those modules to RAM memory or execute from the flash if it's possible. And then I will be able to, for example, mount FAT file system or some others. So ideal solution for my problem is to use file system that supports write operation for configuration file, but also stores files as contiguous memory to allow execution in place. Also, it would be nice to contain power resiliency to handle power outages. If we are not able to destroy data on our file system, that's good, because in case of some bugs or some power outages, it won't destroy a firmware inside it. Also, it's very important to use some optimized file system for NOR flash memory, especially to support wear leveling. Otherwise, we may struggle with bad sectors. If it's possible to that file system to have low memory footprint, it would be best. We may embed this file system into Yasboot implementation and use it to load modules. Also, it's important to have some error handling in case of, for example, bad sectors that exist on the flash. So that file system should find out that the flash is damaged and maybe should relocate some data to another sector. Since we are implementing a bootloader, it's also important to have some security features. For example, to mark partition as read-only and don't allow anyone to modify it. But I was not able to find such file system that supports all of my requirements. In the future, I think I will create my own file system. It is a great project to learn, and I hope it will meet all of my requirements. But let's create some solution for now. I'm going to split my memory into sectors, and one of them will be read and write, and this sector will contain configuration files that may be changed from the system itself. And two read-only partitions. First, primary partition with application, and second, partition with recovery image. Those read-only partitions will be selected from configuration file. Since I did a huge research on the internet about the file systems to find the ideal solution, I selected few of them to compete to be used for temporary solution. For read-only file system, I'm going to use ROMFS because I have ready ROMFS implementation, it's available on my GitHub. And for read and write partition, I'm going to compare LittleFS, JesFS and SPIFFS. I am not going to compare, for example, FATFS because it does not contain word leveling, which is important to me. About ROMFS, it's very simple read-only file system. In fact, its specification may fit on single sheet of paper. Also, it uses contiguous space allocation for files, so it's ready for execute in place, and I was using that file system for that purpose in the past. Tool to create image is available on the internet, so it's easy to create, and since it's very simple, it also has very low memory footprint. To expand your understanding of ROMFS, you can refer to the Linux kernel documentation, which includes a dedicated section on the ROMFS. There, you will find all the essential information required to work with this file system. It's worth noting just how compact the ROMFS is, and it includes the complete specification, like file system header, file headers, and the layout on the single website page. Let's compare read and write file systems. Feature number 1 is power loss resilience. LittleFS is resistant, JesFS is resistant, SPIFFS is partially resistant, so it can be used to be resistant to power loss because it's running file system, but this is not supported by default. Each of those file systems supports word leveling, and also all of them has low resource usage. LittleFS was not created to be optimized on NOR flashes because it was created to be supported by all kinds of devices, and JesFS and SPIFFS are using NOR flash details, and they were created in mind to be supported only by NOR flashes. And SPIFFS is deprecated now, so I think I will use LittleFS as a starting point. Although LittleFS is not optimized for NOR flash, it's still a good choice because it can be later reused for memory cards and other types of memory. Additionally, LittleFS has implemented support for detection of bad sectors. If you are interested in file systems, it's totally worth to check the LittleFS documentation. They did great job while they creating that document. It describes what issues they face and how they solve them. So if you open GitHub page, there is design markdown file, and that file describes how the LittleFS is created, and also if you are more interested in details, there is specification. There is also a great website that describes LittleFS file system, and we can see here the requirements for the LittleFS at comparison to FATFS file system. If we can scroll down, there is a page that describes how much size LittleFS is using, and also there is description about major features that LittleFS is supporting. For example, we can check why power loss resilience is important. There is also a section about word leveling. As we can see, FATFS may destroy device very fast because it's erasing always the same sectors. If you are interested in the topics and you want to get more knowledge, check links in the description. Based on the results of my research, I have selected specific file systems to implement MBR functionality. In the next episode, I will start an implementation of dynamic loader. I look forward to seeing you in next 2 weeks. Goodbye!